All right, let's keep working on rectangles. Since we know that rectangles are parallelograms, we know that these two sides are going to be congruent. So we're going to set them equal and solve. We're going to get the x on the same side. Then we're going to get the x by itself. And end up with 44 equals 4x. And x equals 11. However, we want to find EF, which is this guy right here. So we got to go ahead and plug it in. So 7 times 11 minus 39 is going to equal 77 minus 39, or 38. And that one is done. Come over here. And here we want RT. And RT is this one here. We want US, which is this here. So it's a rectangle. We know the diagonals in a rectangle are congruent. So we're going to set this, let's get the right color. We're going to set them equal. To find x, going to get the x on the same side. Then we're going to get the x by itself. Divide by 3 and get x equals 8. All right, but we want to find VT. And VT is right here, and it's half of one of these diagonals. So we gotta plug it in, and then take half of that. So we're gonna get 5 times 8, which is 40, minus 14 is 26. Half of 26 equals 13. So VT equals 13. All right. So JM, which is right here in the red, and that's x plus 17. And MK, which is half. So half and half, and because we know all these are equal, so x plus 17 equals 5x minus 23. Get the x by itself. Get the x on one side, then we get the x by itself. And we want to find JL, which is the entire diagonal here. So we need 10 plus 17 times 2, and that's going to equal 54. We're doing well, so let's look at a few more examples before we finish this up. All right, VW here is 9x minus 11. SU, which is this whole thing here, and that's 16x plus 12. So it's 1/2 equals a whole. So either we got to do 16x minus 12 over 2 equals 9x minus 11, or we got to do 16x minus 12 equals 2 times 9x minus 11, which is 16x minus 2 over 2, multiplying by 2 to get rid of the fraction. But since this and this are both even, I'm going to start with the one at the top. So we're going to go divide by 2, which is 8x minus 6 equals 9x minus 11. Then we're going to get the x on one side. And we're going to get the x by itself. And we're going to get x equals 5. Now we got to find WT, and WT is going to be half, so it's going to be the same as 9 times 5 minus 11. 9 times 5 is 45, minus 11 equals 34. So WT equals 34. All right, so find the measure of BCE. So we're going to find BCE, which is this purple angle here. Well, what do we know? Well, we know all of these angles are right angles. We know that the opposite sides are parallel. So we know by alternate interior angles, these are the same angle. So we have 7x plus 5 equals 11x minus 3. All right, so we get the x's on the same side. Then we get the x by itself. So we're going to end up with x equals 2. But we want to know this purple angle up here. Well, we know 11x, x is 2, minus 3 is going to equal 19. We know that the big angle, BCD, is going to be 90 degrees. So minus 19 equals 71. So the measure of angle BCE equals 71 degrees. We're done with that one. Number 11, we want to find the measure of JHI, which is going to be this. And by alternate interior angles, we know that this and this are going to be the same. we also know that this angle here is a right angle. So 3x plus 2 plus 12x minus 17 equals 90 degrees. Why? Because all right angles are 90 degrees. So let's combine like terms. 3x plus 12x is 15x. And then we got 2 plus a negative 17 is a negative 15 equals 90. We get the x by itself. So 15x equals 105. We divide by 15, and we're going to end up with x equals 7. And we already established that 3x plus 2 is going to be the same as the angle we're looking for. So we're going to plug it in. 7 times 3 is 21 plus 2 equals 23. So the measure of angle JHI equals 23 degrees. And we're done. Number 12. Number 12. More fun with angles. So XZW, which is this one right here, is what we're trying to find. And we know that this and this will be the same angle, but these two aren't going to add up. Well, these two aren't as helpful because they're not next to each other, but we still know this is 90 degrees and this is 90 degrees. And if 5x minus 8 is ultimately what we're looking for, these are going to crisscross as well, alternate interior angles, or we know that this here is a 90 degree angle, so x plus 20 and 5x minus 8 have to equal 90 degrees no matter how we slice it. So x plus 20 plus 5x minus 8 equals 90. 6x plus 12 equals 90. Then we get the x by itself. 6x is going to equal 78. Divide that by 6. And we're going to end up with x equals 13. But we're not done. We got to plug it in. So 5 times 13 minus 8. 5 times 13 is 65 minus 8 equals 57. So the measure of angle XZW equals 57 degrees. So over and over and over again, we're using 90 degrees, 180 degrees, using our triangles to help us solve these problems. So here we're just going to solve for x. Solve for x. So we know that these are all the same. And since these are the same, we have an isosceles triangle right here. So angle GDF is also going to be 5x plus 7. Okay. We also know that right here we have a linear pair. So 180 minus 134 equals 46. So 5x, 2 times 5x plus 7, or 5x plus 7 plus 5x plus 7 have to equal 134 degrees. So 10x plus 14 is 134 degrees. We get the x by itself. 10x equals 120. So x equals 12, and it wants us to solve for x. We are done. Try a couple for yourself.